All right, so we've got this water trough. We know how long it is. It has the shape of a triangular prism, so I'm looking at the triangular end, which is an isosceles triangle, so it's got equal sides here. The apex is 90 degrees, and it's we're interested in the area of this triangle first, okay? So if I drop a vertical height down, because it tells me that it has a height h, then what I've done is broken this into two triangles, and if I split 90 degrees, I got 45 and 45, but of course, if this is a vertical at 90 degrees, this must be also 45 degrees. Now, if that's the case, then this is a isosceles as well, this little triangle with an h for its length there. So if I just look at, change colour, if I'm just looking at this triangle here, you can see the area is going to be half the base, so h, half of h times the perpendicular height, which is also h, so h squared. But of course there's two triangles, so if I double that, of course, it just becomes h squared. So the area is h squared, centimetres squared. So that's the area. Now, if that's the case, let me just get rid of that so I can see. So the volume of water in the trough, when the height of it is h, well, we know that the volume is A times that 3,000 centimetres. So, and our A is in centimetres squared, so that would be centimetres cubed. So we've got 3,000 times A, which is h squared, centimetres cubed for our area. Of course, we could, for our volume. Now, of course, centimetres cubed is the same as mils. So if I wanted it in litres, I'd just divide by 1,000. So that's 3h squared litres, if I wanted it in litres as a volume. Okay, in terms of h. So, find the volume of water, blah, blah, blah. Okay, B. So the water trough was initially empty. So imagine it's empty and then it's filled with water at a constant rate of 27 litres per minute. So our constant rate is 27 litres per minute. So of course, after t minutes, in t minutes time, of course it started at 0, so the volume is now 27 times t. Okay, now if I equate that to my volume equation over here, that means 27t is equaling 3h squared. And then if I make h squared the subject, I'm just dividing both sides by 3. And if I make h the subject, I need to square root, and I'll take the positive square root because it's a positive height. So my h squared is 9t, my h is 3t, but remember 3 root t, which is the same as 3t to the power of a half. So if I now want to find the height, excuse me, of the water after t minutes, in terms of t, it's that. But what else do I need to find? I need to find dh to t, sorry. So the rate of which the water was rising, so dh to t, a half comes down, so I get 3 on 2, and t to the minus a half. Another way to say that is 3 on 2 root t. So that's my height, which is in centimetres, per time, which is in minutes. So centimetres per minute would be that. So then the next thing I want to do is find the water height and the rate after 25 minutes. So I'm just going to pop t equals 25 into those equations that we just found. So if I put it in that one, so t equals 25 minutes, my height would be 3 times root 25, which of course is 5, so I've got 15 centimetres as my height after 25 minutes. And the rate, so my dh to t here, if I put in 3 on 2 root 25, 25 is 5, so I get 3 on 10, or 0.3 centimetres per minute as the rate of change in the height at that time at 25 minutes. And then we want to do it when the height is at 30. So this time we're given a height of 30. So, excuse me, if I change pens. So now we've got, now we're looking at h is 30, but in those two equations. So if I look at that one at a height of 30, we are going to get 30 equals 3 root t, or in other words, 10 equals root t if I divide both sides by 3. And if I square both sides, I get 100 minutes. So not quite 2 hours, but 100 minutes, more than an hour. So if I then put that time in my dh to t, I can find the rate as well. So I'm going to have 3 on 2 square root 100, which we know is 10. So I'm getting 3 on 20, which actually we can just say it like that. We can say 3 on 20 as a rate, centimetres per minute. Yeah, so that's also the rate. All right, I hope that helps.